details of the topic. And I'm Ege çocuğu. I'm from Iowa. I'm a graduate of Istanbul University. And I went to university to get some graduate study on computer engineering and software engineering. And now I give consultancy and training on Java and software engineering, like design patterns, requirement analysis, object-oriented design and analysis, this kind of stuff. And I'm writing a blog at java.org, and this is where I can be reached at. And I'm the first person who received the Oscar statue from my son, and it reads Great Master of Java. And this is the first joke. And this is, you can read it maybe, but this is one of the first Java certifications that I received in 1998 as a Java programmer. It was then like the 1.1 version of Java. So it's historical, actually. Okay, whenever you want, you can just interrupt me and ask questions. And as part of my social responsibility, I give this kind of lectures, in-class lectures. And hopefully today, I'm going to be starting giving this kind of lectures online on using voxtraining.com platform. So you can go there, voxtraining.com, and search for JavaTurk, and then you can find this kind of print or design patterns or top-down reasons that your Java code is not object-oriented sessions. They are all free and online. You can welcome to join us. Okay. Now this is the agenda. I'm going to just briefly talk about the nature of software and some principles that we can derive from other systems and apply to software systems. And then I'm going to talk about what design patterns mean, and then I'm going to give you a small case study to show you how a design pattern called proxy can help us solve a problem, model a problem, and solve it very elegantly. Okay, now I like this kind of statements. They are very valuable for me, and this is a guy, actually he's a writer, he's not a scientist or something else, but what he says is very important. Most of the time, he says, it isn't that they can see the solution, it is that they can see the problem. Most of the time, we miss the problem, we try to solve a different problem, wrong problem. So this is very common among the computer practitioners, programmers, developers. That's why I just want to quote it here. And we know that, always we say that software is highly complex and infinitely changing. That's why one of the guys in this, great guys in this area, Fred Bruce, says that the most relevant possible solution for constructing software is not to construct it at all. I tried to develop software for more than 15 years, and then I decided that, especially in Turkey, there is no value trying to build software in Turkey. You cannot earn money, you only get bugs and criticism and this kind of, every kind of stress. And that's why I'm not developing software. I'm not trying to teach software, giving consultancy how to develop software, but not to develop software. So this is not a joke. He says, if you can buy, please buy. Do not try to develop software because it is too complicated. Okay, software complicated because of what? What do you think about the reasons of being complicated? It's totally intellectual, right? It's not tangible. So writing software is something like generating a movie, like directing a movie, or it is something like an art. You know, the Donald Knuth says that art of computer programming is kind of art. So it is so subjective, and most of the time, hard to think about because it is invisible. So it is totally abstract in nature. So most of the time, you cannot find two different pieces of software that are similar to each other. If they are similar, you can abstract them under one umbrella. Like if you have two different but similar methods You can make that one method. So every part of software, actually part of the software system, is mostly unique in nature. So having a bigger software cannot be achieved like by having bigger classes or bigger methods. It doesn't mean to have bigger methods. What do you mean by bigger methods? Like longer methods or more complex methods or a method that receives many arguments. So what do you mean by having bigger? Okay? Think about algorithm sorting algorithms. Think about quicksort. But it is bigger. No, it's not bigger. It's very short, but it's very intelligent. So it is very complex. It is so abstract in nature, so mathematical. So it is most of the time it is impossible to define, design, and test the software exhaustively. And most probably the easiest part is coding. So it's so limited by the compiler so that you can understand its nature, but defining what is required in terms of requirements for the people, it is really most of the time it's impossible. And relationships among pieces of the software are not very linear. This is our main topic. We will dive into details of this part soon. And that's why you know this cartoon. Yeah. It's very realistic. Okay, it's funny. It's so funny, but so real. It's hard to comprehend. And Türkçe kulaktan kulağa oynamak gibi bir şey. Herkes aynı dili konuşur ama every speaks the same language, but we keep losing the meaning. Okay? I'm talking about software because it is so intellectual, so abstract. Okay. So second issue, what do you mean by complexity? Defining complexity is not a simple thing. Okay, and one of the definitions about the complexity is made by Dr. Wood. He's not an engineer, I believe he's a professor somewhere in Australia, and he wrote a paper called Task Complexity, okay? And tried to come with a good definition of the constants of being complex task. Okay, he says that there are three parts of task: actions that you do to be able to finish the task, and the Q means information that you know as an input into the process of doing these acts, and these are the products. So products of the task require acts for the task, and information queues for the task totally is the constituents of a task. So if we can define the complexity of these three different items, we can come up with a more analytical definition of task complexity. This is one of the approaches. Actually, you can find many different approaches to task complexity, but this is what we software theorists, not we, but some software people like, and try to apply this to define the complexity of the software. Okay, if we apply Wood's formulation to software, products are the outputs of software. Let's say reports, screens, integration issues, okay, and the information you produce. This is the product of software. Acts are the program units such as classes and methods in software. Okay, we are creating those acts so that in the runtime they can run. Information queues are the data tokens or information that you feed into those program units. Let's say if your program unit is a method, okay, information queues will be its parameters. Okay, so you can make an analogy. I mean, if information queues are like integers or very simple types, it is much easier to understandable. But if you have very complex objects to feed into a method, it's going to be more complex to write in that method. Okay, so that's good. So you can define, create two definitions out of these three types of complexity factors. The first one is component complexity. That's a factor of distinct acts. So part of your program, when you launch, let's say, Eclipse, you have projector, you have many like workspaces, projects, and classes, and methods, Jar files, if we are talking about Java, okay? This is the number of distinct acts. This thing is important here. And number of information queues that you feed into those acts. Okay? So the function of these two means component complexity. This is something like static complexity of a system. Okay? There is no dynamism here, so you can try to find this component complexity by just looking at the project structure of the project. How about coordinated complexity? It's kind of dynamic complexity. So it is actually you can see this kind of complexity, coordinated complexity, during the runtime because it is dependent on the relationships between the acts, how the relationships between the acts are complicated. Okay, is linear or more complicated like a web. Okay, does mean anything to you? I mean, is there any problem in understanding this? Now I'm going to give you concrete examples. Maybe you can crystallize what I'm trying to say here. Okay. The first one, component complexity. We can say cohesion in terms of software. Okay. Component complexity is determined by how acts and data or information are together. Meaning that in terms of system principles, how subparts of a system are together, meaning that focused on just one thing, excluding the others, that means it is more, it is easier to comprehend. So if you have less component complexity, either in terms of this number of distinct acts, or in terms of number of information queues, or in terms of complexities of these two, that means we have easy comprehension, and we can call this situation high cohesion, highly cohesive system. Okay, that means the subparts of a system must be all together in terms of their responsibilities, their focus. Okay, this is called cohesion. The other part, coordinated complexity, is a sibling of cohesion. It's called coupling. It is about relatedness to others. So the first one is knowing about itself. Okay, self-knowledge is cohesion or component complexity, and knowledge about others, this is what we call relatedness, is the knowledge, information about others. In terms of system principles, if a part of that system knows more about itself and less about others, that means more cohesive, highly cohesive, and lowly coupled. So this is more easy, much more easy to understand, to comprehend those systems than the otherwise. Okay? So highly cohesive and lowly coupled systems tend to know more about themselves and less about others. Okay? The objects, if you talk about the objects, object-oriented principles, okay, objects should know only themselves, but everything about themselves. This is very critical. They only know about themselves, but they should so comprehensive that they should not believe, it shouldn't allow any spread of their responsibility to other objects. So it's not something that there's an Ottoman saying called "Efradını cami, ayarını mani." You know that? This is the definition of definition. This is a perfect statement. Ayarını mani, efradını cami, ayarını mani. Efrad means facts, parts. Okay, definition should be so comprehensive that it should include every single detail of a thing that make that thing. Okay, and exclude the ayar. Ayar means the others. Okay.
Sound and complete in English. Sound and complete.
Sound and complete. Yeah. Not only focused but complete. Okay. That's good. Thanks. So object should know as less as possible about others. So object don't gossip. Okay. If an object doesn't need any kind of information, it should know anything about the other objects around that object. So most of the time, more cohesive an object means less coupling it has. So if you try to know more about yourself, okay, that means your relatedness to the other people in your, let's say, family is lesser. Okay? Yani kendiniz hakkında ne kadar fazla bilirseniz, sonuçta kendinize ne kadar fazla odaklı olursanız, dışarıyla alakalı bildiğiniz o kadar az olur. Ve asıl olan şey de bu olmalı. In fact, when you come to like in terms of age over 40s, this would be very valuable to you. When we are young, we mostly find the value in knowing others, okay? Knowing everything except myself would be like very valuable. But when you have like in the maturization process after the 40s, you will definitely find out that knowing himself is more important than knowing others. Okay? This might be philosophical, religional, but definitely this is a system principle in terms of having good software systems. So, highly cohesive and low-coupled systems make comprehension easier. So, understanding will be much easier if you deal with highly cohesive and low-coupled systems. Okay, any questions so far? So, do you agree? Okay. Good. And the second part that makes a piece of software very complex is change. Change is a fact. Okay? So maintenance is mostly changing the software, and most of the time in other engineering products, what is changed is the bad part. But in software, when you have a bad software, you don't try to change it. You just discard it. You try to change good software. Good software means changeable. This is very, very, very different from regular classical engineering approach. So most of the time in software, change is caused by new requirements, new types of users, new types of integration, new types of processes, business rules, etc. And so most of the time, since the maintenance costs much more than development, okay, one of the, let's say, very bad understanding about the software is focusing on just designing for development. Okay. One of the biggest problems of the software industry in Turkey, we are just trying to develop software. We don't think anything about changing software. So we are just developing software and then spend millions of years just to change it. So another perspective for having a good software is design that software for change, not just to use it or build it. Okay. Okay. Let's give a concrete examples. This is a class. It's called system services. When you heard something like system in the name of the class, you should have really smell and bad smells. You see here, this has low cohesion because it doesn't focus on just one responsibility, and because it is talking about employee, department, and login and logout system. So this most probably would have more coupling than this login service, employee service, and department service, because these are more like focused objects. Their cohesion high, much higher than this one. That's why they have low coupling, and this one will be high coupling. So this is obvious, right? How can we say about if we only have program unit 1? This is the perfect case. If you don't have a program unit 2 or program unit 3, if you only have this, you have like zero coupling. But that's not a system. So quality of no infinite cohesion, no zero coupling is possible. How about the coupling, quality of coupling of this part and this part? What do you think about? What can you say about the between this coupling and this coupling? Let's say there are two developers. The first developer would be responsible to handle this part. The second developer would be responsible to handle this part. So which developer do you want to be? Of course, first one, right? Because this is high cohesive object. Talking to high cohesive objects makes coupling much easier than talking to low cohesion object. So what I'm trying to say, even though they look like the same level of coupling, the nature of this coupling is much worse than the nature of this coupling. Now I'm going to give you an example. When I talk about the coupling, the quality of the coupling is really important, and we may have different kinds of couplings. No coupling at all. This is the best coupling. Okay? This is loose coupling because only clients knows about service. This is tighter coupling because they each know about each other. Okay? So this is unidirectional, this is bidirectional. How about this coupling? Client only knows the interface of many different objects. Meaning that client doesn't exactly know about what is in there in terms of subclasses of this service interface, but client only knows how to handle service. That's why you can write this kind of programs. When we have schedulable, when it's just an interface, we have subtypes of the schedulable, employee can be schedulable, equipment can be schedulable, and conference room can be schedulable. Okay? So if we have a schedule, if we have a method to add schedulable for this date, time, and duration, that means the implementation of this class should must not know about anything specifically equipment, conference room, employee. Okay? The only knowledge schedule should have only the parent type of these concrete types. You know, polymorphism is polymorphism, right? So you can write schedulable as an assignment near employee. Okay? A type of schedulable can point to different types of its subtype. Another actually more elegant explanation of the polymorphism would be something like this. Two objects, let's say schedulable and equipment, okay, they switch information, okay, they communicate with each other without knowing their exact types. That's really great. This is the pinpoint, the most important point, having object-oriented systems. Two guys can communicate without knowing their exact types. They can only know their parent types. Okay? That's flexibility. Okay, so when we think about coupling, we should always keep the coupling level of the coupling as an abstract. That's why we can say program an interface, not an implementation. Okay? The coupling should be at the level of interface, not at the level of implementation. That's why we are saying that encapsulation hides the implementation of the details of the implementation and exposes the interface. So the reason of existence of a class can only be its responsibilities exposed through its interface. Okay. So objects only know about their responsibilities. This is what we call responsibility design. So everything, the coupling, reason of the coupling between the objects is to implement responsibility and give the service about this responsibility. Okay, so let's come to design patterns. And So far, we have several principles. We should have highly cohesive objects, lowly coupled objects, and if we have program to an interface, not an implementation, we can achieve this. And we should design objects for change, not just for today. Okay? So these are our principles. And let's see how design patterns guide us to have these systems according to those principles. First of all, design patterns. First of all, let's talk about design. Design, you know, tasarım. Pattern, how do you translate pattern in Turkish? Örüntü, I don't like this.
Yeah.
Okay. Örüntü. Kalıp, şablon, desen. Okay. I'll give an example. What pattern means for a typical American. Okay. When I bought, okay, I used to always wear the kazak pullover that my mother made for me. Okay. When as a child, when I say walking on the street, most of the time, okay, other women come to me and say to me, "Stop! I'll just take the example of this. Bunun örneğini alacağım. Kazağın örneğini alacağım. That's pattern. Yani o örneği aldığı zaman ondan halı çıkartabilir. Tamam mı? Pattern'da hani bu anlamda desen bu bir good. Hani kalıpları da tercih edebiliriz falan yani. Neyse, design patterns, first of all, will help us find responsibilities correctly. So, implementing responsibility-driven design would be much easier when we apply design patterns. Distribute those responsibilities among objects by paying attention to cohesion, coupling, and change. Okay? So there is a methodology how to distribute those responsibilities to correct objects so that you can have highly cohesive, low coupled objects and easily changeable. Okay? And this is the main two actually idea to use design methods. So when you define design patterns, they solve frequently seen software design problems in terms of highly cohesive and low coupled objects. You know the history of design patterns? Who first coined that term, design pattern? Christopher Alexander, and he's not a computer scientist. He's just an architect. Okay. Eric Gamma, one of those people in design, very well-known people. I believe he was a roommate of this guy at the university. Okay. And then apparently Christopher Alexander unique guy in terms of thinking abstractly, and he is writing books like Timeless Way of Building in terms of how people keep using different design patterns in architectural styles. Okay, he says this is very unique sentence regarding the design patterns. Each pattern describes a problem which occurs over and over again in our environment. So it's talking about a problem, okay? And then describes the core of the solution to that problem. And there's a solution for that problem in such a way that this unique part, you can use this solution a million times over without ever doing it at the same time twice. So that means that solution is so abstract that you can customize that solution to your concrete problem. Okay? So most of the time we say that design patterns are independent of languages. We cannot talk about the design patterns of Java. We can only talk about idioms of Java, okay? Idioms of C or C++, but we can talk about the patterns of design, or patterns of performance, patterns of security. Okay? So in this sense, a design pattern is an abstract and reusable solution to a common problem. What do you mean by a common problem? The first problem, how to create objects. In the class, you can see just in your classrooms, new customer. But it will be very difficult if that customer would have like tens of arguments. How do you create complex objects? Okay, so creation would be really a process. That's why we have patterns. How to control the access an object? An object is very valuable. Okay, you want nobody can directly access to that object. Okay. How to specify multiple ways of performing a task interchangeably? Let's say you have like different items that you apply different sorting algorithms. How can you apply those sorting algorithms without, transparently for the client? The client doesn't know anything about how to change among these ways. How to give commands to objects? Do this. How to abstract commands? How to implement event mechanisms among objects? Okay. How to give different abilities to objects during lifetimes? Like you have just 1,000 Turkish liras and you spent that 1,000 Turkish liras to buy a car. Definitely it wouldn't be a Maserati or Ferrari, maybe just Hajimura. Then, when you get some more money, how can you elaborate or decorate your car so that it can be beautiful? Okay, that's quite frequently seen from how to manage complex states of an object. Let's say our object is the door. Okay, you can manage the state of objects just using one Boolean variable, open or closed. If it is open, you cannot open it. If it is closed, you cannot close it. To be able to close it, you make sure that it is open. Okay? So think about an object with 10 Boolean variables. So how many states do you have? 2 to 10, right? 1024. How can you manage this complexity using only if and else structures? That's what we call sinir var, en azından procedural programming. Okay? So keep using many if and else so that you cannot even understand what you wrote yesterday. How to say state of an object and retrieve it later? Memento, right? There is a movie called Memento. How to handle many objects as a bundle. Okay? How to apply an operation to many objects. Okay? So these are some of the unique and very common problems when you come across when you develop software. So these are the constants, part of the design patterns. And when you talk about this design pattern, you definitely talk about name. So name is identifying part of the design pattern. When you say single developer, okay, every single developer in the world understands the same thing. Okay? When you talk about finite state machine or state pattern, everybody understands the same thing. Okay? And intent, the main purpose of the pattern for the singleton is something like this. Make sure that there's only one instance of a class and provide a global accessibility to it. That's the main motivation. We make sure that nobody would create objects of a class, but only there is one object of a class so that everybody can use it. Okay? That's very common. How about problem motivation? This is the explanation of the context in which this pattern reveals itself. Solution structures, participant and collaborators, consequences, implementation details, some maybe example course in small code, C++ or C#. Generic structure that you can give a standard diagram in terms of UML, let's say class diagram or sequence diagram, so that people can understand the in terms of the pattern. Applicability, I can apply this pattern. And some sample code, known use and related patterns are among the parts of defining a pattern. Yes, sir.
What's the participant or pattern?
Participant of the pattern, like different interfaces, different abstract classes, different classes, they play together to be able to implement the pattern. So the classes, the entities in this class diagram will be participants of that pattern.
So what's the implementation is the exact implementation.
Oh,
Exact
yeah.
process.
Right. Now, when we talk about the participants, we mostly talk about the entities involved in the pattern, and we give a diagram to give more like correct meaning of the formal meaning of how they collaborate. Okay, and this is the implementation. This is the exact sample code for the pattern. Okay, and why to use design patterns? First of all, it is reusable. Tekrardan keşfetmeyelim. It creates a formal and common language. You know, most of the time, when I work as like managers of developers, they come together, they talk hours and hours, and then they go away with different things in their minds because they don't know how to talk about software formally. Okay? So when we say this is singleton and we are managing the states of an object here using finite state machine, that means like hours it saves hours of or days for you. So I remember when I first come across with the pattern, I was working for GE and in a company of GE, when they tried to give information regarding the code base of the system, it was a huge e-procurement system, okay, so 1997 or something. Okay, the guy who designed, who is one of the designers of that software, told me that we are managing the states of shopping cart through state pattern. That's it. It's just one sentence saves maybe 1 month of hours of giving examples, trying to make sure that I understand the concept. So it creates formal and common language because it's hard to talk about abstract things. So power to abstract away details while focusing on higher objectives. And those young guys always ask me, how can be a senior software engineer, software programmer? Writing lots of programs doesn't make anybody like an architect, okay? Unless you think in terms of higher abstractions, okay? The thinking in terms of design patterns gives you the power to abstract away the details and focus on the right thing, like change, cohesion, coupling, and these are the main tenets of the quality of the software. Design patterns give us a methodology to avoid potential pitfalls of procedural programming. Have you seen huge Java programs using zero statics? I always see. They say that, oh, we are using Java, and they think that since they are using Java, it's going to be high quality software system. So it is quite possible to do any büyük günah, very simple things in terms of software by just using Smalltalk or Java. Having a Ferrari or Mercedes doesn't mean that I will obey the rules of the traffic. Okay, so design patterns, if you don't use design patterns, most of the time you will find yourself writing procedural code using Java. Hani şey var ya, bu Şahin bölümü, Doğan bölümü Şahin. Çok komik. All Java code, but all procedural. Okay, now these are the main books that you can have more information design patterns, and this is the Bible of design patterns. This is the unique book, and almost every other books about design patterns is the explanation of this, tefsir of this. Okay, so this is invaluable book written by Daniel Fogg, 4. chapter, based on Hal Johnson Ulysses. One of the, I guess this is the professor Urban Champion, as I know. And the second book just came after this book is Bushman's book. This is the System of Patterns book. This is a good book too. But when we talk about design patterns, 99% of the time we talk about Gang of Four. Okay? And it is not only a book, but a catalog for the design patterns. And it gives 23 patterns in 3 different categories. So 5 patterns in creation part about how to create objects, very complex objects, how to abstract away the details of creating an object. This is about structural patterns, how to define the structure between objects so that we can have like more changeable things. And this is how to do the behavioral, the more dynamic kind of patterns in here, behavioral patterns. But be careful about just delving into the details of design pattern because it is really hard to understand. Okay, so my advice would be like take a design pattern class or reading a book, something like Head First Design Patterns for high school people. Okay, it's very easy to read. It gives examples in C++, so if you don't know C++, it might be hard to understand too. But even though it is very hard to comprehend this book, the first 2 chapters are incredibly good in terms of summarizing the object-oriented principles. It talks about 3 principles in these 2 chapters. First one, program-time interface, time implementation. Second one, prefer delegation over inheritance. Third one, design for change. Okay? So the philosophy of these 3 things are very extensively studied in these 2 chapters. Okay, these are the 23 patterns, and this is the map for the patterns because they have some relationships among themselves. This is the last page of that book. And I forgot to bring the book here because in my car. Anyway, this guy had for design patterns. Okay, that might be the first book you can read on design pattern if you don't know more experience on programming experience. Okay, and this is a good book too. And design pattern explained. This is the tafsir explanation of the Gang of Four book. And you know, this is Freddy Merman. And there's a Turkish book, okay? Most of the time, I don't like Turkish books because they don't have any quality, but Özcan Acar, Almancı yaklaşımız. It's a simple book, okay? Very simplistic. So you can have, like, start with and start reading this to understand the design patterns. Okay? Now, I'm gonna have a case study here. We have a problem. Okay, I'm explaining the problem here. So, using Gang of Four's proxy pattern, proxy means vekil. Okay, proxy pattern. How can we solve this problem? This is a very common problem. Okay. Now, the first item in the problem in democracies. So far, do you have any questions? Okay. In democracies, citizens have the right to reach the people that govern themselves. This is the definition of the democracy, perfect democracy. Okay. And PM, Prime Minister or Başbakan, as the highest governor, has the responsibility to listen to citizens for their requests and has the right to respond as he wishes. Okay, that's another item in the problem. But it is not practical, not only practical, but also not secure to allow 75 million citizens to reach PM. So there's a very valuable object. Okay, this is valuable guy. But on the other hand, this has been elected by citizens so that they see that they can have the privilege to talk to you. Okay? How can we manage this situation without violating the democracy and security of the PM? Okay. We can, if you think of let's start with this. How about responsibilities? So what are the responsibilities? What do you think about the responsibilities in here without just creating the objects? Like listening to citizens, right? That's a responsibility. Talking to PM is a responsibility. When we talk about this responsibility, we can say that message or operation or behavior of the objects. Okay? These are different approaches to the same thing, actually. So, listening or responding are the responsibilities for the PM, right? How about for students? Responsibility or behavior to talk to PM, right? When we come up with an initial design for this, okay, we can have two participants, citizen and PM. Okay, citizen tells about its problems to PM and it listens. Okay, and when student asks about for a job, okay, PM finds a job in his way. Okay, so this is the responsibility of PM is listening and finding a job. Responsibility of citizen is telling about its problems and asking for a job. Okay, so this might be the first thing that comes to our minds in terms of their interaction. So main problem is that citizen directly reaches the PM. So he cannot control this coupling to PM. How about putting like a proxy in here between citizen and PM, so that citizen talks to vekil, proxy, and proxy talks to PM. How about this guy? Okay. Citizen comes to proxy, proxy listens to citizen, and then delegates, okay, what he has in mind to PM. What's the problem with this? This violates the principle of democracy. In this case, citizen doesn't directly talk to PM. That's so obvious. And this is something like when you invite citizen to talk to proxy, you will say, bring Prime Minister. I just want to talk to him. Okay? So this problem too. So what might be the solution? We are close to solution.
Proxy may arrange some time of Prime Minister to citizen.
You are saying that this is something like secretary, okay? He says, here is the Prime Minister.
Yeah.
But still, we come to this point too. It directly talks to PM.
No, proxy talks to PM and say that this guy wants to talk to you. How about tomorrow?
Okay.
Okay.
Proxy says that there is a deceased guy, okay, waiting in the door. He looks like a good guy, okay. He will, he will give you no harm. And then later, Prime Minister comes here to talk to citizen, and then citizen, let's say, kills him with invisible thing.
And,
Even though,
moreover, how does the proxy decide if a citizen is secure?
even though you would definitely make sure that there is no harm from citizen, it is not practical every single citizen directly talk to PM. Because we don't have such time. We don't have any utilities to arrange this. Okay? Now, okay. There's a trick in here. Let's do this way. We create, okay, definitely we should block citizen talking directly to PM. Okay, that's for sure. But we should create such a mechanisms that citizen would think that he is talking to PM, but in fact he's talking to proxy. That means we must make this proxy and PM exactly, they should look like exactly the same thing. How can we make two objects look exactly the same? So that citizen would in reality talk to proxy, but he thinks that he's talking to Başbakan. How can we do this?
Impersonation.
Impersonation, psychology impersonation, correct. But in terms of our code, we must make proxy and PM implement the same interface. Okay? What does it mean look the same in terms of objects? Looking the same means having the same interface. Okay? Let's create a PM. That's an interface. It listens to and finds a job. Let's create two different implementations of this interface. The first one, real PM. This is the guy we try to protect. And this is the proxy PM. But only we know that this is proxy. Okay? Because they look like the same. Because we can write PM, P, new proxy PM. And then P assigned new real PM. That's polymorphism. Okay? Now, student comes to PM secretary or Başbakanın kalemi and says that give me PM. It returns PM. Okay? The return of this method will be PM, but in the runtime, it returns the object of proxy PM, not this one. Okay? Now, I'll show you the code here so that you can easily understand. This is the code in Turkish. Okay. This interface Başbakan, that dinle, strip that, and then iş bu, strip yakın. Hamili yakınındır. That's the responses of the Başbakan, and that's its implementation. Gerçek Başbakan says that, okay, he says the proxy that, please listen that for me, okay, and bring them to me. On the other hand, for İşbul, he says that, don't come to me by this kind of request. Bana böyle isteklere gelmeyin. Because he chooses how to respond to those two different inputs, right? Okay. He is listening, but he is not listening in case of İşbul. That's the gerçek başbakan. How about vekil başbakan? Okay. It has the same interface, so it is listening to that. It says vekil, derdinizi dinliyorum. And for the İşbul, vekil, isteğinizi dinliyorum. İş bulmak isteğinizi dinliyorum. Now, what is the trick part? Did you notice this part in here? Okay. Even though they are of the same type, okay, the instance of real PM is part of the proxy. This is the problem coming from the citizen, and then according to some rules, okay, established, let's say by PM, it delegates what is listened by in here itself in vekil, okay. It delegates it to real PM. That's why we have here like gerçek başbakan as an instance variable of the vekil başbakan. So that means vekil directly knows the başbakan, okay, and citizen knows about vekil başbakan, but he thinks that he's talking to real başbakan. So it looks like tricky, but it is quite legal, right? So, since Başbakan says that, okay, bring me the debts, vatandaşın derdini bana getir, okay? That's why when we call this debt dinle, when citizen call this debt dinle, it delegates this debt to gerçek başbakan. But how about here? It doesn't do anything, okay? Because Başbakan doesn't want to listen to this kind of requests. Okay. How about vatandaş? Okay. When we create vatandaş, we just pass Başbakanın kalemi, okay, secretariat for the PM, and it says give me Başbakan. give me the Prime Minister, and it gets the Başbakan, and you see this is the type of the interface, not the exact type of the gerçek Başbakan. Okay? So he thinks that he's talking to Başbakan, but in fact, kalem dot bana Başbakanı ver method returns vekil Başbakan. You see, this is kalem, and when you call bana Başbakanı ver, it just returns to an instance of vekil Başbakan, but it looks like a Başbakan. Okay, so and this is the test. Okay, I'm just creating a kalem and then vatandaş Rıza and passing kalem, the secretary for the Başbakan to vatandaş, and Rıza says about that and asks for a job, and let's see what happens. Başbakan says that, of course, sir, and then vekil, I'm listening to you, and then it delegates. This is what it listens to Başbakan. Başbakan says, okay, that's a problem. How about for this issue step, vekil just say, I'm just listening to you, but he's lying. He's not even listening. Okay. So what do we get? Like in terms of this proxy pattern.
You have to finish it again first.
Okay. This is the last slide. And okay, we just protect this very valuable object from the citizen, but citizen doesn't think so. We achieve this creating two different objects, and those objects look the same in terms of their common ancestor. So citizen thinks that he's talking to Prime Minister, but there are many Prime Ministers. Okay? There might be many proxies, but only just one real PM. So if you know about like Corba or web services or Aramis, they are all working on this kind of remote proxies patterns, and very expensive objects, like you are launching a project, launching a runtime program, but you don't want to load expensive objects. You can just load their proxies until you really need this real object. Or laser loading, they are all just implemented using these proxies. So it is very common. Okay, thanks for listening, and you can get this